Hello students, let us try to understand the next topic, that is enthalpy. Here is we are having the next concept is enthalpy. So what is enthalpy, student? Enthalpy in general terms we said that is change in energy. Okay, we directly say that is change in energy. But let us try to understand in thermodynamics what is meaning of enthalpy. Like what we have already understand, that is ionization energy, ionization enthalpy. So energy means what? Enthalpy means that is it can be either absorbed or released. But the same way here you see in the thermodynamics how we define the total heat content of a system. Okay, the total heat content of a system at constant pressure and temperature is called enthalpy. So enthalpy is what, student? At constant pressure and temperature. At constant pressure and temperature, the total heat content. Okay, the total heat content of a system at constant pressure and temperature is called enthalpy. It is a state function and its extensive property. What is meaning of this state function? State function means what, student? Its value depend on initial state of system and final state of system, while it is saying that is extensive properties. Extensive properties means it is depending on the quantity or the size of matter present in the system. So that both the things you have to keep in mind, that it is the state function and extensive properties, and it is the total heat content at constant pressure. Now let us try to understand. It is calculated as sum of the energy, sum of internal energy and product of pressure and volume work. So how we can calculate the total heat contained with the help of internal energy and pressure volume work. Okay, the sum of internal energy and pressure volume work is known as what? Enthalpy. Now it is impossible to determine the absolute value of enthalpy. So absolute value you cannot determine, so we use, so we use what we use, student? We use that is delta H. Okay, so delta H is process can be calculated as delta H is equal to delta U plus PV means what, student? PV means W. W means what, student? P delta V. So that directly W is equal to what? We are writing the at the place of, in this equation, at the place of PV we are writing the W. Now for infinite change at constant pressure we can write at delta H is equal to delta U plus P delta V. Okay, so that is if the change is there. Okay, if the change is there in the volume here and internal energy is there, so delta H is equal to internal energy plus pressure volume work, that is delta V. It is a exothermic process. It is a exothermic. What is meaning of exothermic? That is delta H is negative. If when it is endothermic, delta H will be positive. Means that is enthalpy of product is less than the enthalpy of reactant, that is Hp minus Hr is negative, so that is exothermic. And what about the endothermic? Same way, that is Hp is greater than Hr, means enthalpy of product is greater than enthalpy of reactant, so delta H is equal to delta that is Hp minus Hr, that is delta H equal to positive. So here we can write that is enthalpy release, standard enthalpy, that is summation of enthalpy of formation of product minus enthalpy of formation of reactant. Okay, next point. The difference between enthalpy and internal energy, delta H and delta U, not usually significant for the system consisting only solid state and only liquid. The difference, however, becomes significant when the gases are involved. So in the gaseous state, enthalpy and internal energy, relation between enthalpy and internal energy is quite important. Now that let us understand, that is some problem based on the enthalpy. What is enthalpy? What is enthalpy in simple term? Okay, this is the question. Enthalpy is a concept used in the science and engineering when heat and work need to be calculated. So when you are going to calculate heat and work, we are using the term enthalpy. When a substance changes the constant pressure, when the substance change at constant pressure, enthalpy tell us how much heat and work was added or removed from the substance. Enthalpy is similar to energy but not the same. Okay, next point. How do you define the enthalpy? How do you define? Enthalpy is sum of the internal energy and product of pressure volume of a thermodynamic system. If symbol, the enthalpy H equal to sum of internal energy E and the product of the pressure and volume V, the system H is equal to E plus PV. Next point, what is there is student, that is what is enthalpy and internal energy. That is both the term we are going to define. Already internal energy has been defined. Now let us see. Internal energy is the total energy contained in a system. Internal energy is a total energy contained in a system. It is the sum of potential and kinetic energy possessed by the system. Okay. So internal energy is the total energy contained by a system. What is the enthalpy? Enthalpy is defined as sum of internal energy and this energy of the system plus product of pressure, volume, work in the system is known as enthalpy. So internal energy, if you are calculating internal energy, so that is delta U is equal to, we are saying that is kinetic energy plus potential energy. Okay. But when you are talking about delta H, so they are saying delta U plus pressure, volume, work. So this is what is the difference between the enthalpy and internal energy. Next question, student, they are saying enthalpy is positive or negative. So delta H is equal to, if the positive, this is what is the endothermic. Now student, what is the, if delta H value is coming, that is negative, so it is what is exothermic, right student? Now what they are saying, delta H greater than 0, delta H greater than 0, the change in enthalpy is positive, which means that energy is being absorbed. This is called an endothermic reaction. And delta H is less than 0, the change is negative, which means that energy is being expelled. This is called exothermic reaction. Okay. Now you see the one more definition, last definition. Enthalpy is the property of thermodynamic system defined as the sum of system internal energy and the product of its pressure, volume. It is convenient state function preferred in many measurement in the chemical, biological and physical system at constant pressure. Okay, so H is equal to E plus PV. So H is enthalpy, E is equal to internal energy, P is pressure and V is the volume. Okay. Now here see student, enthalpy, what they are saying, enthalpy is total kinetic energy, potential energy of a system at constant pressure. Okay. So total in it is, you can say, at constant pressure, what you are saying, sum of kinetic energy, potential energy. Okay. Another term they are saying, change in enthalpy, change in heat of the system. So delta H is equal to H final minus H initial, or delta H is equal to H product, enthalpy of product minus enthalpy of reactant. Heat is means by which energy is transferred. For a process carried out in constant pressure, the heat absorbed equal to change in enthalpy. So delta QP is equal to delta H, that is enthalpy change. P denotes constant pressure. Enthalpy is a state property, which means it depends on the initial and final state, not the path between them. So that is delta H is equal to H final minus H initial. So the enthalpy of reaction, if you are calculating, that is enthalpy of product minus enthalpy of reaction. So this is all about the enthalpy of the enthalpy, student. In the basic terms, if you want to understand, enthalpy is what? That is total heat constant at constant pressure. So here the pressure will be constant, student, and it is the total heat content. How mathematically we formulate? Mathematically, enthalpy change is the change in internal energy plus pressure, volume, work. So here we can see delta H is equal to delta U plus W, or delta H is equal to delta U plus P delta V. So these things you have to keep in mind while solving the problem. Thank you so much for watching, friends.